Gurubhyo Namaha. We are going to see the concept algebraic expressions and identities. Algebraic expressions is nothing but the combination of variable and constant. Here I'll write the one example. So further, this expression can be divided into terms. Totally 3 terms are here. So 4x square, 5x and 6. Totally 3 terms. Then the terms is divided into factors. So 4x, 5 into x, then 6. So this is nothing but the polynomial. Polynomial further divided into 2 categories. Based on the number of terms and the degree of the polynomial. Based on the number of terms, we can divide the polynomial into 2 categories. The expressions that are having one term is a monomial, 2 terms binomial, 3 terms trinomial. More than 3 terms is a polynomial. And based on the degree, the expressions with 1 degree is called linear polynomial. With the 2 degree is quadratic polynomial. The highest degree of the expression is called cubic polynomial. The number is 3. So there are 2 different kinds of polynomial. One is monomial, binomial, trinomial. The another one is linear, quadratic and cubic polynomial. Now we are going to see how to add, subtract the algebraic expressions. First we will see addition of algebraic expression. So how to add these 2 expressions? First write the like terms together. See 3x square plus 5x square. These 2 are first like terms. Then take the second pair of like term. 5y minus 3y. Then plus 3z plus 6z. So write the like terms together. See the variable, here is x square and here is also x square. So these 2 are called like terms. So 5y and 3y, 3z and 6z. Now we are going to add the number 3 plus 5, 8x square. Then 5 minus 3 plus 2y, then plus 9z. So that's all. This is the answer for addition of this polynomial, algebraic expression. Now we'll see how to subtract the polynomial. Subtract 3xy, 5z from the question is subtract this expression from the second expression. First we need to write this expression because we are going to subtract this from this. So first write the second expression, 7x square minus 5xy plus 7z. Then minus, write the first expression inside the bracket. So 3xy plus 5z plus 6x square. Then the next step is write the same expression again because we are going to multiply the minus inside the second bracket. Now multiply the minus inside the bracket. So minus into plus. See, Here it's plus, so minus into plus minus 3xy. Come to the next term, minus into plus minus, so 5 is it. Then minus into plus minus 6x square. See, as we did in the addition, we need to group the like terms together. So the next step is we are going to group the like terms together. So 7x square, check what is a like term, minus 6x square. Then the next term is minus 5xy, then minus 3xy. Then plus 7 is it, minus 5 is it. So now do the addition or subtraction as per in the question. 7 minus 6 is x square. Then minus 5 minus 3, this is integer concept. The terms with the which is having the same sign, we need to put the same symbol. So minus 8xy, then 7 minus 5 is 2 is it. So this is the final answer. See, first we wrote the second term, second expression first, then minus first expression, then we multiplied minus inside the bracket. So plus into minus minus and minus into plus minus, then add the write the like terms together, then simplify the expression, you will get the final answer. So this is the method to do the subtraction of the algebraic expression. Now we'll see multiplication of algebraic expression. Now we are going to see how to multiply monomial by a monomial, monomial by a binomial, polynomial by a polynomial. First, I'll give example for monomial by a monomial. Already we know that what is monomial. The expression which is containing the one term is called monomial. First example, this is one monomial. I am going to multiply with another monomial. So monomial by a monomial. First multiply the numerals 3 into 5, then into variable. So 3 5 are 15 into x into y. So 15 x y. So this is the example for monomial by a monomial. Suppose if you are having exponent in the monomial, for example x square, y cube. How will you do the multiplication? So 3 into 5, one more a variable will add. So x square into x cube into y cube. So 3 5s are 15. So the base are same, so we can add the power. This is nothing but the laws of exponents. So x power 2 plus 3 into y cube. So 15 x power 5 y cube. So this is your final answer. So this is the multiplication of monomial by a monomial. Then I'll give an example for monomial by a binomial. Monomial, binomial 3a plus 4b. So this is a monomial and this is a binomial. Now we are going to do the multiplication. First multiply this term inside the bracket. 5x into 3a, first term over, then second one, plus 5x into 4b. Now multiply the numerals. 5 3s are 15. Then write the variable as ax plus 5 4s are 20. 20b x. That's all. This is the final result. We cannot simplify this because both the terms are having different variables. Here x is same, but a and b are different. So we cannot simplify furthermore. So this is the example for monomial by a binomial. Now I am going to give an example for polynomial by a polynomial. This is the last example. Polynomial. This is also type of a polynomial. First, take the first term into the second bracket, second expression. So 3x multiplied by 2x plus 7y. Then take the second term of the first expression plus 2y multiplied by the second expression minus 2x plus 7y. Then take the third term of the first expression and multiplied by the second expression. You have to take the terms of the first expression multiplied with the second expression. So 3x into second expression, 2y into second expression, minus 3z into second expression. Now this is nothing but the monomial into binomial. So 3x into 3x into 7y plus 2y into minus 2x plus 2y into 7y. Then come to the third one. I'll rub here. Third one, minus 3z into minus 2x plus 3z into 7y. So listen, we are multiplying this monomial into the binomial. 3x into minus 2x plus 3x into 7y. Come to the second one. 2y into minus 2x plus 2y into 7y. Come to the third one. 3z into minus 2x plus 3z into 7y. Now we are going to multiply everything. Plus 3 into minus 2. So minus 6. X into x, x square. So first one is over. Then come to the next one. 3 7s are 21. See, there is no negative term, so we can write this symbol plus. 3 7s are 21. So 21xy. Come to the next one. 2 into minus 2. So plus into minus, minus. So minus 4xy. Then 2 7s are 14. 14 y square, because y into y already we learned the laws of exponents, so y square. Then come to this one, minus into minus plus. 3 2s are 6. So 6x is a two different variable. Then plus 3 7s are 21. Y is it. Now check, is there any like terms are there? I think there is no like terms, because x square, xy, here is, see, these two are like terms, because the terms containing the same variable xy and xy. So we need to simplify this expression. So minus 6x square plus 21 minus 4. So 21 minus 4 is 17. So 17xy. Then no other like terms. So we'll write 14y square plus 6xz plus 21y is it. That's all. This is the way you have to do the multiplication of expression, algebraic expression with the other algebraic expression. Now we'll see an identity. We have finished addition, subtraction, multiplication of polynomials. Now we are going to see identity. What do you mean by identity? See, consider the equality. For example, x plus 5 into x plus 5. This is nothing but the product of the binomial by a binomial. First, find out the product of these two. X square, already we have learned how to do the multiplication of binomial by a binomial. So x into x, x square, then x into 5, 5x, then take the next term, 5 into x, 5x, then 5 into 5, 25. So x square, these two are like terms, then add the like terms 10x plus 25. So this is your LHS, x plus 5, x plus 5. This is your LHS and this is your RHS. Suppose when you substitute the value of the variable, suppose I am substituting x equal to 1. So take LHS, if you substitute x equal to 1 in this expression, what will you get? 1 plus 5, 1 plus 5, so 6 into 6, 36. So your LHS value is 36. Now we will find the value of RHS. The value of x is 1, so 1 square is 1, 10 into 1 is 1 plus 25. So 25 plus 10, 35, 35 plus 1 is 36. Check the value of LHS and RHS. So both are same. So this type of equality is called their identity. In this class we are going to see 4 types of identity. One is a plus b the whole square. Another one is a minus b the whole square. A square minus b square, and the last one is x plus a into x plus b. Yeah, these are the 4 identities which we are going to learn now. A plus b the whole square is a square plus b square plus 2ab. A minus b the whole square is a square plus b square minus 2ab. A square minus b square is a plus b into a minus b. Then x plus a into x plus b is equal to x square plus a plus b into x plus ab. So these are the 4 identities which we are going to use in the product of the algebraic expressions. So now we'll see the application of identity into the product of algebraic expression. How to apply the identity in the product of algebraic expression. For example, x plus 5 into, we'll take some other example, x plus 3 into x plus 3. How will you find the product of these two expressions? See, this is of the form a plus b into a plus b. Already we know that a plus b is a plus b the whole square. So we can use a plus b the whole square identity. Here a is equal to x and b is equal to 3. We know the identity a plus b the whole square is equal to a square plus b square plus 2ab. Already I have learned how to substitute the value of the variable. Here the value of the variable a is x and b is 3. So a value is x, so a square is x square and b square is 3 square plus 2 into x into 3. So a value is x and b value is 3. So answer is x square, 3 square is 9 plus 6x. So we found the answer by using identity. So I'll give some another example. So this is of the form a plus b into a minus b. So what is the answer for this identity? A plus b into a minus b is nothing but a square minus b square. Here a is equal to x, b is equal to 7. So the answer is x plus 7 into x minus 7 is equal to x square minus 7 square. 7 square value is 49. So this is the final answer. This is the way you have to apply the identity in the given product of the algebraic expression. And one more example is how to find the product of a number without using actual multiplication. Suppose for example 103 the whole square. So how will you find the value of 103 the whole square? First we need to split up the number into 100 plus 3 the whole square. I hope you all understand the concept. See, this is nothing but a plus b the whole square format. Here the value of A is 100 and B is 3. So by using the identity we can find the answer. A square plus B square plus 2AB. So 100 square is 10,000, 3 square is 9 and 2 into 100 200, 200 into 3 600. So add everything, you will get the final answer. So 103 the whole square value is 10609. So this is the way you have to apply the identity to find the product of the number without using actual multiplication. Almost we covered all the concepts of algebraic expressions and identities. Thank you. Now we are going to learn the concept factorization for class 8. See, already you have learned the algebraic expressions, terms, coefficients and types of polynomial. Now you are going to learn how to factorize the given polynomial. For example, let us give some example. 4xy, 5x comma x plus y. The expressions are like 4xy and 5x comma into x plus y are already in terms of product of the factors. For example, how will you factorize this binomial? So to factorize the given polynomial, totally 4 methods are there. First method is method of common factor. Next is regrouping the term. Third one is using identities. Then last one, factors of x plus a into x plus b. First we'll see first method, method of common factor. Let us take an example. 4xy plus 5y. So what is the common factor in it? So we can write this as 4 into x into y plus 5 into y. So what is the common factor in this binomial? So y is common, take common factor out. Then what is remaining? 4 into x, 4x, then this plus, then 5. So this binomial expressed as the product of the factors, two factors, y into 4x plus 5. I'll give one more example. (49x square plus 7xy). So now we can write 49 as product of prime factors 7 into 7 into x plus 7 into x into y. Now check how many common factors are there. So number 7 is common and the variable one variable is common, that is x is common. So we'll take common factors out. 7 into x, 7x, then open the bracket, write the remaining term inside the bracket. 7 into x is 7x plus then y. So already we took 7x out, so 7x plus y. So this is the required factor of this polynomial. We'll see second method, method of regrouping terms. Let us consider the example 2xy plus 2x plus 6yz plus 2y. Totally 4 terms are there in this expression. Now we are going to group first 2 terms, then next 2 terms separately. In the first 2 terms, what are the two common factors? 2x and 2x. So take 2x as common, then take what is remaining? Y plus 1. So here what is common? 2 will change the problem. 6y square. So 2y is common So y plus 1. So now compare these two terms. See, when we compare these two terms, the common factor is y plus 1. Then the remaining is 2x plus 2y. Then after that, check this terms inside the bracket. We can take 2 out from here. So 2 into y plus 1 into x plus y. So these are the factors for this expression. This is the method of regrouping term. Then the next method is by using identity. Factorization by using identities. Already you have learnt 4 identities. By using first 3 identities, we are going to factorize the given expression. I'll write the identities here. A plus b the whole square, a minus b the whole square, then a square minus b square. Let us take example x square plus 10x plus 5. This is the quadratic polynomial. We are going to factorize this quadratic polynomial by using identity. This is of the form a square plus 2ab plus b square. Now compare both the expression. Here a square is equal to x square and 2ab is equal to 10x and b square is equal to 5. So we are going to rewrite this equation as x the whole square, a square, then 2ab, 2, a is 1, we'll change b later because it should be perfect square number. So we'll take 16. We need to change the entire problem because both the terms should be perfect square number. We'll take 16, then 2 4s are 8, 8x. So 16. Then 2a, b is 4 plus 4 square. We can write this 16 as square of 4, 4 square. Now here a is equal to x and b is equal to 4. So x plus 4 the whole square. Because a square plus 2ab plus b square, we can express this as a plus b the whole square. So listen, this is a given question. Excuse me, sir. This is a given question, x square plus 8x plus 16. Check the first and last number. It should be a perfect square number to factorize this by using identities. First number is x square, is a perfect square number, and the last number is 16. This is also a perfect square number. So we can rewrite this expression as a square plus 2ab plus b square format. So we can take a plus b the whole square. So a plus b the whole square. So the factors of this expression is x plus 4, x plus 4. So this is another method to factorize the given polynomial. I'll give one more example. X square see, this is the given expression 4x square minus 24x plus 9. So check the first and the last term, both are perfect square number. So we can write this in the form of a square minus 2ab, because here it is minus. So minus 2ab plus b square. So here a is equal to 2, because we can write 4x square as 2x the whole square, then 9 as 3 square. So here a is equal to 2 and b is equal to 3. The middle term is 2ab term. So a square minus 2, what is a here? A is 2x. Change values. So 2x plus 3 the whole square, because this is of the form a square minus 2ab plus b square. So a minus b the whole square. So the factors are 2x minus 3, 2x minus 3. We'll see another example. By using third identity, 49x square minus 36. So we can write this as 7x the whole square minus 6 square. So this is of the form a square minus b square. So a plus b, already you know the identity, a plus b into a minus b. This is the way you have to factorize the given polynomial by using identities. The last method is the factors in the form of x plus a into x plus b. Factors in the form of Now let us give an example. P square plus 6p plus 8. Check the first and the last term. Last term is not a perfect square number, so we cannot use first three identities. So compare the x square plus RHS of this identity. Compare this and with identity. Middle term should be sum of such that a and b as a factor of this polynomial. So sum of the factors should be 6 and the product of the factors should be 8. So we need to select the two numbers, that is the factors of 8. What are the possibilities? 1 8s are 8, but sum of 1 and 8 is not equal to 9. So this is not possible. Then the second option is 2 4s are 8. So 2 plus 4 is 6. So this is the correct option. So we'll take 2 and 4. P square plus, see these are the two factors such as a and b. Compare this, write it in the form of this one. So a plus b p plus 4p plus 8. Then regrouping the term method. First take p common. Compare these two terms. What is a common factor? P. So p plus 2. Then the next two term 4 is common. So p plus 2. So now take these two terms. The common is p plus 2. Here the remaining is p. Then plus and the remaining is 4. So the factors of this expression is p plus 2 and p plus 4. So these are the four methods to factorize the given polynomial. Next we are going to learn divide the polynomial by a polynomial. First we started with monomial. Division of algebraic expression. Division of algebraic expression. Let us start with monomial. 14x square y divided by 7xy. So first split the number into product of prime factors. So 14 we can write it as 7 into 2. Then x into x into y. Then divide by 7 into x into y. Then cancel the common term, common factor. X and x get cancelled, y and y get cancelled. So what is remaining? 7 and 7 get cancelled. So what is remaining in the numerator? 2x. So this is the answer. So this is a method to find to divide the monomial by a monomial. Last example. Suppose you are getting this type of question, polynomial by a polynomial. So we need to factorize the numerator first by using last method. We'll take first expression x square plus 7x plus 12. Again we need to take two factors such that the product should be 12 and the sum should be 7. So we'll take 12. What are the chances? 1 12s are 12, but sum is not equal to 7. So this is not possible. Then what is the next chance? 6 2s are 12, but sum of 6 and 2 is 8. So it is also not satisfied. Then 3 4s are 12. So 3 4s are 12 and 3 plus 4 is 7. So we can use these two number. So split up the middle term. X square plus 3x plus 4x plus 12. Then take first two terms, then the next two terms separately. Take the common thing out, x plus 3. The common factor is x and x. So take x out. The remaining is x plus 3. Then 4x plus 3. Then when we compare these two, x plus 3 is common. Then x plus 4. So these are the factors of this expression. Just write this expression in the numerator. X plus 3 into x plus 4. And the denominator is x plus 3. Then we can cancel the entire factor x plus 3. The remaining is x plus 4. That's all. This is the required answer. This is a way you have to divide the polynomial by a polynomial. So far we have learned how to factorize the polynomial by using 4 methods and division of a polynomial by a polynomial. Thank you. Now we are going to see the concept in direct and inverse variation for class 8. See, in our daily life we will come across some phrases like more you spend, more you buy, more you spend. The less you buy, the less you spend. The faster is the speed of the car, the lesser is the time taken to cover a fixed distance. More men working on a project, the time is lesser to complete a particular project. In these phrases, when all the quantities are depend one on each other. See, if two quantities vary, x and y, the value changes in one causes the corresponding changes in y. This is called variation. There are two types of variation. One is direct variation and another one is indirect variation or inverse variation. So two types of variation, direct and inverse variation. First we will see what is direct variation. Let me give an example. Number of books cost in rupee. So number of books represent the value of x and number of cost is represented as y. Cost of one book is 20, two book is 40, 3 book 60, 4 80. So you can observe that the change in one quantity, affect the change of the other quantity. So we'll find the ratio of corresponding x and y. 1 by 20 then x by y 2 by 40. If you simplify this, you will get 1 by 20. Then come to the next one, 3 by 60, 1 by 20. Then 4 by 80, so 1 by 20. So we can observe that all the ratios are same. If two quantities x and y vary, the ratio of the two quantities remains constant. This type of variation is called direct variation. In direct variation, the ratio of x and y quantity is constant, is equal to k. So let us see example related to direct variation. In this question, x is vary directly as y. So x is directly proportional to y. We know that in direct variation the constant is x by y. So x, we are going to find out the unknown value. Let us take this unknown as p. So the first ratio is 2 by p, and we know that both the ratios will be equal. So 8 by 18. Then do the cross multiplication. So this will become 2 into 18 is equal to 8 into p, and this will become as a denominator. So 2 into 18 by 8 is equal to p. So when you cancel this, you will get 18 by 4, therefore p is equal to 9 by 2. So this is your value. By using direct variation, we can find the unknown value for the given question. Now we'll see one statement problem. Let us see one statement problem for direct variation. Rima types 540 words during half an hour. How many words would she type in 6 minutes? First we'll represent this question in the tabular form. Number of words, time in minutes. So 540 words can be typed in half an hour. We'll change the time into minutes. Half an hour is equal to 30 minutes. Then how many words would she type in 6 minutes? So the time is given. We are going to find out how many words is going to type within 6 minutes. So let us take this as x, unknown value as x. We know that number of time decreases, the number of words will also decrease. So these two are in direct proportion. So x is directly proportional to y. So we know that the constant of direct proportion x by y. This is x and this is y. So 540, first we'll find the ratio of first x and y. 540 divided by 30, and the second ratio is x by 6. We know that both the ratios are equal in direct variation. So equate both the ratio, then simplify this by cross multiplication. So cross multiply this 6. So 540 multiplied by 6 by 30 is equal to x. Then simplify this. Therefore, x is equal to 108. So she can able to type 108 words in 6 minutes. So this is the example for direct variation. We'll move on to indirect variation. So the constant for the direct variation is x by y. Now we'll move on to the indirect variation. So let us start with the example. Men one day. So this is nothing but the example of number of men working in a project and number of days to complete the project. See, number of men given as 40. 40 men can complete a work in 1 day. 20 men can complete the same work in 2 days. Similarly, the informations are given. Now we'll find the ratio of this information. We'll find the product of these two variable. 40 into 1, 20 into 2, 8 into 5, 2 into 20, 1 into 40. The product of two quantities will be equal. So the two quantities x and y vary such that the product of these two values is equal. Then we can say that these two quantities are in indirect proportion, otherwise inverse proportion. So for inverse proportion, the constant is x into y. So this is x1. So x1 into y1 is equal to x2 into y2. Similarly, all the product will be equal. So this is called inverse variation. We'll see example how to solve the problem by using this concept. Let us see example for inverse variation problem. If 35 men can reap a field in 8 days, in how many days can 20 men reap the same field? We'll represent this question in tabular form. Number of men and number of days. So this is x and this will be y. So 35 men can reap a field in 8 days. In how many days can 20 men reap the same field? So we'll mark the unknown as y. See, we know that number of men decreases, the number of days time taken to complete the same work will increase. So one quantity decreases, the other quantity will be increases. So this type of variation is called inverse variation. We know that for inverse variation, the product of the two quantities will be equal. The constant. We need to find the constant of the inverse variation. Already we have learned what is the constant of the inverse variation. X into corresponding y is equal to the next value into the corresponding y, the unknown value. Because in inverse variation, the constant is the product of the respective value. X into y is equal to x2 into y2. Now, the multiplication will become division in the opposite side, cross multiplication. Then cancel. 7 5s are 35, 4 5s are 20, 4 1s are 4, 2 4s are 8. So y is equal to 14. So 20 men can reap the field in 14 days. So the answer is 14 days. So far we have learned the types of variation and the problems related to this variation. Thank you.